This paper was presented at the JCT Traffic Signals Symposium 2023 in Nottingham, thanks to the support of AGD Systems, INRIX, Message Maker Displays, PTV Group, Simplify Systems, Smart Micro UK and TRL Software.
Right, thank you for having me. So what's all this about anyway? What have they all got in common? And what have they got to do with buses? More on that later, I think. Right, so I'm here today to tell you how we, in network performance delivery and TfL, help buses on the network. And I'm going to tell you a little bit about something called the RARR program. I'm going to tell you what it is. I'm going to tell you how we formulate the program. I'm going to tell you what we do. And I'm going to tell you why it's good for buses. Before I go into all that detail, just want to remind you of a few numbers about the TfL bus network. It is the biggest, most extensive network in the world. I'll let you read the numbers yourselves, but a really nice soundbite that we've managed to get out from our UTC system recently is that in London, 2/3 of all buses either arrive on a green signal or receive some type of bus priority. And I think that's really strong. And that's really down to the hard work that we've been doing in the department to make sure that we are getting more and more out of the equipment that we have. And I have presented on that in previous symposiums. And I can show you those numbers in a little bit of detail here. So the top left bar chart there shows you over the period we've been collecting data, how many buses we see in London every day. So this is every time we detect one on a virtual detection point. And you'll see that in the last few years, that has been steadily increasing. Before the cynics consider you're running more routes in London now, no, we're not. Actually, the number of routes in London have been going down. So we're seeing more buses in London, even though there's technically fewer out on the network in terms of routes. That's because we're getting better at fixing faults, we're getting better at updating our bus priority configurations, and we're getting better at getting more out of the equipment we've got on street. In a similar kind of trend, the bottom left graph that you see there shows you a breakdown of the bus priority that we get each day on our system. So it shows you the number of extensions we give and the number of recalls. And again, they have been slowly going up and up over time as well. And this really is in reflection of all the time review work that we do and the work that I'm going to talk about today. So we're seeing more buses, we're giving more bus priority. The top right pie chart there, that's where I get the 2/3 figure from. You'll see a lot of buses do arrive on a green signal. That's the best type of priority. I always say to everyone, best priority is just a pure green signal. You're not messing with anything else. And then there's a small breakdown in terms of recalls and extensions, and that makes up the 2/3 figure. Right, so let's jump to what I'm here to talk about, which is the RARR program. So RARR stands for the Route Analysis Recommendation Report. And what it basically is where we look at a bus route in London from end to end in detail. We get lots of information about that route, and we just want to make that route better. So that is what the RARR program is targeting certain routes in London and making them better. The map there on the right-hand side shows you all the RARR routes that we've done since we started this program back in 2016. So we've got good coverage, but there's a lot of routes that we could still look at and a lot of parts of London we haven't got to yet. So the program was established back in 2016, 2017. It uses numerous little kind of data feeds and information that all comes together. We do one RARR every period, or we kick one off every period to do 13 across the financial year. And each one, when we start it off, each individual that owns that RARR, it takes them 5 periods to do it, or about 20 weeks. So how do we come up with a program? We've got over 700 routes in London. How do we know what 13 to look at each year? So we go to our bus colleagues in the bus directorate, and they supply us with a weighted list of 100 routes. And you can see the information that goes into that weighted list there. So we get a long list of 100 routes. And then what we do is we take that weighted list and we look at, for example, a few things to knock out and get out the 13 that we want. So we remove the ones that we've done in fairly recent previous years. We don't want to keep going over and over looking at the same route again. We remove routes that don't have many signals on them. If there's not many signals, it gives us limited ability from a signal perspective to make those routes faster. And there's very other sets of criteria that's in the paper that's been published. Ultimately, we are looking for poorly performing routes that have potential for good improvement. This is this year's program. And you'll see there's a nice geographical spread across London. That's on purpose. We want to try and reach the whole of London and do a spread across London. You'll also see there's a spread across the operators, and again, that's intentional. if we did all 13 routes for one particular bus operator, it wouldn't make all the others happy. So there's some politics at play. So we try and get a really nice rounded program. The one caveat to this is that when we pulled this program together in March, just I think around in April, there was something called the Superloop was announced and kind of being launched in London. If you haven't heard of it, the Superloop is a mayoral priority to create a big express bus loop in outer London. And if you see the X26 there, if you were to continue that kind of circle all the way around, that is essentially what the Superloop's going to do. Now the X26 is on the Superloop, and we kind of knew it was coming, so we put the X26 at the start of our program. The X26 is now something like the SL5. I can't remember the precise number, but ultimately this is subject to change, what you see in front of you now, and we are focusing on the Superloop. Right, so the process itself that we go through, you can kind of break it into three sections. The startup phase, there's an implementation or doing phase, and then there's a closeout phase. And in the period of startup, this really is data gathering and information gathering from all different sources, so we know what we're looking at on that particular route. We'll go to the bus operators, the ones who run the route every single day, and we'll talk about their pain points, congestion points, issues that they have, anything that they can tell us from their experience we want to know. We talk to the area teams and MPD, so we can find out about major schemes going on the network. We can find out about why signals work, how they do, so we don't come along and change them unnecessarily. So we use them for some information. We extract the bus priority configurations for that route, and we make sure that the bus is actually being seen at every junction that it's going through. We use our UTC system data to see how bus priority is configured, to see if there's things that we can do with signal timings to make it better. And we also use iBus performance data, so hard data that tells us where routes are running fast and running slow. And then we do something called the route walk, which is one of the key activities in the Bus RARR process. So we can get all this information, but we want to get out there and we want to feel the route and we want to understand it. So what we do is we go out early in the morning and we ride the route from one end to the other. Ideally, we sit at the top deck of the bus and we sit out front and it's a really nice ride, but we're looking at the whole route and how things work. And then we walk it back, the whole route in the other direction. And they're probably normally about 30 miles or so. So if you cast your mind back to the first slide, on a nice hot day, we do eat ice cream. You always need a good pair of trainers, probably need sunglasses. If it's wet, you need an umbrella. And we do it all year round, so when it's cold, we wear hats, gloves, whatever it takes to be out all day. I haven't quite got to the level of needing a foot spa yet, but maybe as I get older, I'll need one. So that's what ties it all together. Those things on that first slide are kind of my equipment locker, if you like, for this particular piece of work. But getting out on the network, it really lets us feel how the bus works, live it, breathe it, understand it. And we use that and supplement it with all the information that we've got already. So on the route walk, absolutely everything and anything is considered to make the bus route faster. We want to explore the issues that have been highlighted, that the data's shown us, that the operator's shown us, and investigate them in a bit more detail. And we want to come up with new ideas to make the route better. And all these observations, we effectively filter into 4 buckets that you can see there. I tend to record the route on Strava just for posterity, just see how far I've walked each day. And the RARR selfie is becoming fairly popular now. So there's a nice picture of us out on a route walk. And Mr. Buck, who'll give me a wave, was the one in charge of the Route 65, so he's in the audience today. So we go out, we get some pictures, we look at stuff. So just to talk you through what we precisely look at when we're on the route walk. The first bucket, broadly, are faults. So we do look at faulty detection. We look at whether call cancel units are working for pedestrians. We look at IRDs, we look at MVDs, are they faulty? Are stages appearing when they shouldn't? Are things being delayed by stages being called and delaying the buses unnecessarily? And you can see here, this particular junction, stage 2, 276 appearances out of 276 opportunities. So we can use data from our system as well to see where demand-dependent stages are coming in, possibly when they shouldn't. In a similar kind of vein, we look at misaligned detection. So the detectors could be working fine, they're maybe not auto fault reporting, but the alignment might not be quite right. And that goes for pedestrian, cancel detectors again. It goes for IRDs and MBDs, and this little example here, real example from a RARR walk that we did, where left-turning traffic was turning off the junction and turning through an IRD detection zone and calling phase C, side road, and stopping the main road for buses unnecessarily. So what we did, we noticed that, and we reported a fault, got the IRD realigned. It seems really simple, but unless you go out and see these things, you're not going to solve them, and this is going to bring tangible benefits to those bus routes. So we look at the stage appearance as well. We look at poor signal optimisation. Now we're out all day. We walk through loads and loads of junctions, so we only see a little snapshot of how they're working. But in our kind of experience and observations, we can see if things are working kind of as they should, and if not, we can note it down and investigate further. So we do look at scoot loop positions or magnetometer locations. Are they in the right place? Are they causing problems for optimization? Can we move them? We look at poor junction balance, and this again is a real example from a route walk we did through Wembley, where the side road was just getting oodles and oodles and oodles of green, and we write that down and investigate it later. It could be totally legitimate, but if it doesn't look quite right, we want to investigate that. And the last thing we look at is faulty signal equipment. I mean, some extreme examples here, but we look at whether things are out of alignment, whether there's faulty lamps, damaged poles, etc. And the reason we do this, aside from it being the right thing to do, because we want the signals to be in good health, these things could lead to more significant incidents down the line, which leads to the journey time unreliability on bus services. So we go out and we try and correct all these things. The second bucket that we look at is enforcement. So we look at parking and loading, we look at existing bays, locations, hours of operation, and whether even people park and load where they shouldn't in the first place. We look at bus lane use or abuse, really, and we look at banned turns and whether people are undertaking manoeuvres that are delaying buses. All these things are noted down, all the locations are noted down, and we can pass them on to the TfL compliance team. The third bucket is quite a big one, and I see this as a really big opportunity for improvement for us. So this is where we can identify. My favourite schemes are the small signal schemes, the kind of low cost, quick to implement, good impact schemes. So we can look at where we see push and walk activity in implementing pedestrian cancel detection. We can add delay timers, so if you see pedestrians wandering through zones that they shouldn't and inserting a spurious demand, we can add delay timers to control a configuration. We can look at adding demand dependency on quiet side roads if it's not there. Or we could look at using a 5-second traffic min. And again, Chris in the audience presented on the using 5-second traffic min more in London now. So we're looking for these opportunities as we go. And just purely other simple method of control efficiencies, such as combining side roads that may be used to run separately. We look at amendments to the parking and loading bays. So maybe they need to be there, but are the hours okay? We look at bus lanes. Can we implement bus lanes? Can we change the hours that they're in place, or can we increase the hours that they're in place? Absolutely anything and everything else. Geometry, line markings, everything. Road surfacing, we look at. Because I remember a really bad section of surface near Brent Cross where the buses were really slowing down because the surface was so bad. So we reported it to the maintenance team. The final bucket is something which is totally in our control in network performance delivery to deliver, and that's timer reviews, bus-focused timer reviews. So as we go along the route, we look at where things are maybe not optimal. We compare it to our UTC system data, and we can identify timer reviews that we can add to our program to be done within the period of the RARR. And the Route 13 here, we identified 9 locations along that where we could do some focused timer reviews and improve bus priority. We take all these notes, and over the course of a walk, it's probably between 75 to 100. It could even be more sometimes, and we put everything in an action log. And then we move on to the doing phase. So this is where we actually get the stuff done. All the faults that we note, we report to our maintenance contractor, and we make sure they're resolved. All the enforcement points, we raise to the enforcement team for them to pursue. Sorry. We investigate all our scheme ideas. Are they feasible? Are they viable? And then we can raise them to TfL engineering. And then the timer reviews, again, that's something that we can raise, add to our time review program, and spend time tuning up the system. In the closeout phase, we do some benefit measurement and we do some reporting. So we look at iBus data before we visited a site and iBus data after. So at sites where we've made a significant difference, we go along the route and we pick those out and we aggregate them up, and we can come up with a benefit value for the work we've done across the route. And we create a time review summary report that we can then distribute to the bus operators, and we can share with area teams and bus colleagues to show the worth of the work that we've done. And the final slide I just want to close on just gives you a little highlight of last year's programme. So we did 13 routes last year. We walked 133 miles of the bus network. Of the schemes that we identified, 119 of those have been pursued. And we reported and made sure 78 faults were resolved. And we did 77 bus-focused time reviews on those routes as well. And you'll see the average benefit figure that we got out there is 96.16 passenger hours of benefit on each route that we did. For me, I think this piece of work, or the work that we do, has relevance not just for buses. You could do a cycle-focused corridor or a pedestrian-focused corridor, or any kind of corridor management. So you can take this and apply the theory of looking at what you've got and squeezing a little bit more out of it. And that's a real common theme that we've been talking about recently. And Darren, I think you're in the audience, I saw you earlier. You mentioned yesterday Team Sky and the aggregation of marginal gains. That's something which I totally buy into, believe the philosophy. And for me, if we make 30, 40, 50 little changes, some of them not even little, along the course of an entire bus route, you can actually have a real big impact there. Thank you very much.
Thank you, Michael. I mean, I think one of the things I want to say is that I'm glad you made the point that this is just as applicable to other routes, because I think we can all have a tendency when time is busy to not get out of the office and actually walk it, cycle it, whatever, and see it from the user perspective.
Yeah, yeah.
Brilliant. We've got a speaker already, a question already. Just in the middle here.
Hi there. I was just wondering if you could explain the 96 that bus.
Yeah,
bus per route.
the 96 hours of benefit.
Does that translate into seconds saved? And the other question was going to be, are you sort of focusing on actual bus journey time reduction or reliability, or a bit of both?
So the 96 hours saved, I knew I was going to be asked this, so I kind of thought about it. We know how many people are on each bus through passenger data, and we know we've got a tool where we've got journey times, the time it takes for a bus to travel through a certain segment. And effectively what we do is we look at that journey time saving, so it could be 20 seconds, and then we multiply it up by the number of people on the bus, and that gives you a figure of passenger seconds up to minutes saved. And then we can just aggregate it up for each of the junctions that we do. And sorry, your second question was about?
Reliability versus journey time. What's your focus?
So for us, it's quite a simple remit. We're in the market of making the bus move faster through the network. It's then the bus directorate who, I mean, TfL works on headways. So if we're speeding things up and we're maybe compressing some headways, they need to look at their scheduling. So I'm not the expert in TfL who deals with all of that. From our remit, it is very much go out, make the bus faster in every way possible. And then that's why we engage with them. So once we've done that bit of work, we can show them what we've done. And then probably, I think it's when the route's retendered, they would look at the scheduling and possibly even be able to remove a bus from the service.
Brilliant, thank you. We've actually got quite a number of questions. So we've got one down here and two up at the top there. Paul, do you want to go first?
I did some research in what they call transit in the States, and there was a baffling number of people that work in buses that never actually take them. They just drive everywhere. And there was, when they were mandated to take the bus, suddenly the performance of the bus skyrocketed. Do you have an expectation of your team, and is there an expectation within TfL that if you're working on the buses, you actually travel on them?
So obviously people who work for TfL live all over. I actually live outside of TfL and take the train to work, but I'm a firm believer in using the network. And we do loads of site work in everything that we do. I'm not told to get off my train early and take a bus into the office that would take 5 times as long. But there is definitely an encouragement to use the TfL network where possible, and I think people do travel around it on using it.
Thank you. We'll go first to the gentleman who's been very forceful about his arm, and then we'll go on to Dom next.
Started aching. Tim Ray from Unix Traffic. My colleague James obviously presented Fusion yesterday, and he talked a lot about the potential improvements in terms of reduction in congestion. However, one of the things that we failed to mention was that what Fusion also does is allow you to prioritise different modes. Have you got any plans? Have you already started plans to bring the Fusion functionality in terms of giving buses priority at junctions as part of your programme, and if not, is that part of the future aspirations?
So I'm in the TfL team who are going to be the users of Fusion, but there is a satellite team to us who are the ones developing it with Unix.
Okay.
I believe that they are investigating, looking at the bus priority element, and it will be there. I'm not sure precisely how it's going to work, what it's going to do, but in due course, I imagine we'll be informed and trained on it.
Yeah, yeah. A lot of our customers are very keen to understand that, because that's perhaps where funding alignments are coming from in terms of funding future investments in Fusion. So it's not all about congestion reduction.
Yeah.
Just to mention, we have started testing bus priority in Fusion in London, in Leytonstone, on a couple of sites. I think I put a picture on LinkedIn about that when we were doing it earlier this summer. So, yeah.
I'm hoping to come out and see it, I think, James, at some point.
Yeah. Great.
Thank you. Over to Dom.
So excuse the potential ignorance of the question, but how close are you to providing other cities with a black box solution for bus franchising? Obviously, the DfT set out plans to levelling up to let get other cities closer to London. Mm-hmm. It looks like Manchester's been working away for ages on its own, toiling away. Other cities might be doing it. Can you just go to a city and say, you want franchising? This is how you do it. This is how you find the routes. This is how you optimise them. This is how you. These are the contracts you use. How close are you to doing that, would you say?
I'm afraid I'm really not best placed to answer that. I mean, in the team that I do, we are kind of at the sharp end in terms of dealing with bus priority and getting signals to it. I mean, we're not called signal engineers anymore, but we've been called signal engineers or traffic engineers for the majority of my career. So we're the engineers really, rather than the policy makers, or whether there is something in the TfL bus directorate or someone that could do that, I'm not too sure, I'm afraid.
I know we've got Jenny down here, and sorry, John, but there's a little hand up in the corner there. It's all about hands today.
Yeah, do you do any actual testing virtually on the schemes that you put in? So when you're doing lane changes, road markings, signals, or do you just estimate that it's highly likely that there's going to be an improvement?
So we would, for certain schemes, absolutely. Like, I wouldn't be able to propose, let's say, the full signalisation of a non-signal roundabout without doing some level of modelling support. I say the signal schemes, my favourite ones are the kind of pragmatic no-brainers. I think Rory was talking about no-brainers yesterday. Like, if we see pedestrian push and walk activity, we would raise a scheme to put in pedestrian cancel detection. Those kind of pragmatic quick win schemes are the ones that we really look for here. Low cost, quick benefit, low lead time. But certainly for the bigger schemes that we do, or we're proposing fairly major changes on the network, we would do modelling.
Thank you.
Right, Jenny, you have to keep this very, very quick.
First then, a very quick invitation. When you're walking the 128, you're very welcome to pop in for coffee and cake. So bear that in mind. Secondly, thank you. Really good, interesting presentation. I had no idea that you did all this. If I were you, in addition to the engineering and the technology piece, I'd want to do a slight bit of human piece. Maybe we enjoyed the great psychology presentation yesterday morning. I'd want to involve operators, and I would specifically want to talk to drivers.
We do actually.
You do?
Yeah, we do. So when we get to routes early, because we go to the start of route, the driver's often milling around, and we do not all the time, but if the driver's open to it and receptive, then we do have a chat with the driver and get their take on things as well. Yeah.
Brilliant. Thank you, Michael. Can we give a big hand to Michael?
Just do something very quickly?
Oh.
Is this all right?
Oh,
I actually told my 7-year-old that I was presenting today, and I've been sending him little pictures of the symposium, and he said, "Daddy, can you take a picture of yourself with everyone in the auditorium?" So I'm going to do a selfie. We're going to do a RARR selfie. You can come in. Right. Thank you very much. He'll like it.